Alright, in this video we're going to talk about rational exponents, which really just means we're looking at exponents that are fractions. So something we need to first define is the word index, which is the small number to the left of the radical symbol that tells us which root to take. So for example, if we had just a square root, a cube root, and a fourth root, the index is the little number right here, and on the square root we don't put that, but the index number is actually a 2. We just don't physically write that. Now we can rewrite any radical as an exponent. Say we have the square root of x. We rewrite that as x to the 1/2 power. If we had the cube root of x, we rewrite that as x to the 1/3 power. And if we have the fourth root of x, we rewrite that as x to the 1/4 power. So to generalize this, we can say the following: that any number raised to the power of 1 over n is equal to we call it the nth root of that number. So in a more general form, we can say if we have x to the power of 1 over n, that's going to equal the nth root of x. So let's look at a couple examples. Here in example 1, we're going to simplify each expression. In the first expression we're going to simplify. We're going to do 2 of them here. We're going to first look at 125 to the power of 1/3, and then we're going to also do 64 to the power of 1 over 6 plus 25 to the power of 1 over 2. So first let's take care of A. We have 125 to the 1/3 power. We can rewrite that as the cube root of 125. Now we can break this up, ask ourselves what times what makes 125. We can say 5 times 25. We're breaking it up into prime numbers. 5 is already prime, so we'll just carry that through. 25 is 5 times 5. And when we find the cube root, we're looking for a group of 3 of the same number, and we've got 3 5s, so the cube root of 125 is 5, which means 125 to the power of 1/3 is going to just be 5. We could also use a calculator to figure this out. But let's look at B. We're looking at the 64 to the 1/6, which means we're looking for the 6th root of 64 plus 25 to the 1/2 means we're looking at the square root of 25. 64, let's break that up. I know that is 2 times 32. 2 is prime. We'll keep breaking 32 up. We've got 2 and 16, which we can keep breaking up, 2 and 8, 2 and 4, and then 4 goes into 2 and 2. So we're going to look for 6 of the same number, and I see 6 2's. When we're looking for the sixth root, we look for 6 of the same number. So we're going to have 2 plus 25. We're looking for the square root. We break that up into 5 times 5. Square root means we look for 2 of the same number. We've got 2 5's. So 2 plus 5, which is equal to 7. So our answer is 7. And that wraps up example 1. So we've looked at examples where the fraction in the exponent has a numerator of 1. But what do we do if we have a different numerator? Like, what if we have x to the power of 2 over 3? What do we do then? Well, let me lay the rule out for you. So what we say is a number raised to the power of m divided by n is equal to the nth root of the number raised to the mth power. So what that means with this x to the 2/3, we write that as the cube root of x and then we square that. We can also write it as the cube root of x squared. So if we generalize this as x to the power of m over n, like our rule here says, that's going to be equal to the nth root of x to the power of m, or the nth root of x to the power of m. Let's look at a couple of examples. So again, in example 2, what we're going to do is we're going to simplify the expression. And the first one we're going to look at, 2a we'll call it, is going to be 216 to the power of 2/3. And then the second one is going to be 32 to the power of 4 over 5. So what this means is we are taking, for example 2a, the cube root of 216, and then we are going to square it. So we want to figure out what number times itself 3 times makes 216. So we're going to break that up. I look at this and I see that all the numbers add up to 9, so I can divide by 9. 9 goes into 216 24 times, and then I can break 9 up. Is 3 times 3. 24 is going to be 3 times 8. Then I need to break 8 up. That's 2 and 4, and then 2 and 2. So since this is the cube root, we're looking for trios, 3 of the same number, and we've got 3 3's and 3 2's. So 3 times 2 is 6. So this is going to be 6 to the power of 2. 6 squared is 36, which means 216 to the power of 2/3 is going to equal 36. Now in B, we're taking the fifth root of 32, and we're going to raise that to the 4th power. So first let's break 32 up. I know 32, we can write that as 4 times 8, and 8 is 2 times 4, and both 4's can break up into 2 times 2. So we're looking for 5 of the same number since we're finding the 5th root, and I see 5 2's. So we're taking it and raising 2 to the 4th power. Well, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So our final answer is going to be 16. Now let's look at one final example where again we're going to just simplify, but this time instead of having numbers, we're going to have variables in our problem. In the first one, we're going to have the cube root of x to the 9th times y to the 3rd. Now I'm going to say on a problem like this, let's immediately rewrite this as x to the 9th, y to the 3rd, to the power of 1/3. Because then we can use the rules of exponents we talked about in our last video. When we take the power of a power, we multiply the powers. So we've got x to the 9 times 1/3 and y to the 3 times 1/3. And 9 times 1/3, that's going to just give us 3. So we're going to have x to the 3rd. And 3 times 1/3 is just 1. So we're going to have just y. So our answer is going to be x to the 3rd y. Let's look at one more and then we can wrap up this video. We're going to have x squared y to the half. And then we're going to raise that to the 4th. And then we're going to also throw in a cube root of y cubed. So let's always just say, rule of thumb, we'll start off by rewriting any radicals as an exponent that's a fraction. So we can just take our first part, the x squared y to the half to the power of 4, and just rewrite it. And then we're going to take our y to the 3rd and raise it to the 1/3 power. Now we've got powers of powers, so we can multiply those. So we're going to have x to the 4 times 2, y to the 1/2 times 4, and y to the 3 times 1/3. Well, 4 times 2, that's 8. So we're going to have x to the 8. 1/2 times 4 is 2. So we're going to have y squared. Y to the 3 times 1/3. 3 times 1/3 is 1. So we're going to have just a y to the 1. And we're almost done. But we do have two bases of y's with powers, so we can add them. So in our final answer, we're going to have x to the 8, y to the, when we add 2 and 1, we're going to get 3. So our final answer is x to the 8, y to the 3rd. And that's going to wrap up our lesson on rational exponents.